1,200 kilograms, is moving in a horizontal circle of radius 80 meters on a road banked at an angle of 12 degrees to the horizontal. When a car is moving with a constant speed of v meters a second, there is no tendency to slip. We want to calculate the normal reaction of the road on the car and find the value of v. So let's start with a diagram of our question. So I'm just going to draw it as if the car's driving towards us, so that we can resolve the forces acting on that car. So I like to do crosshairs through the centre of our car. So acting downwards there is our mass of 1200 Gs. Now of course we have then normal reaction, which will act perpendicular to the plane. So here is my reaction acting there. Now, the reason I do this full kind of crosshair at this point in time is because you have to remember that the acceleration is acting towards the center of the circle, so we have to resolve according to this very important fact here. And this is the important key aspect of circular motion. Okay, so the angle at the bottom there is 12 degrees. That must mean that this will be 78 degrees. This angle here would be 12. This angle here would also be 12, and what's nice is the angles just alternate, so this will be 78, and this angle here will be 12. So remembering that I can only resolve horizontally and vertically because this acceleration acting towards the centre of the circle. To find a reaction resolving upwards, we're going to have R cos 12 degrees is equal to mass times minus the weight mass of the car, which is 1200 G, is equal to mass times acceleration. There's no acceleration perpendicular to that, horizontally, but vertically like this, which is why we've got to resolve horizontally and vertically. So this is equal to 0. So then R is equal to, if I subtract the 1200 G from both sides and divide by cos 12, we get that the reaction will be 1,222.73 newtons. And that's the 2 decimal places. Okay, now we've got the normal reaction. We can find the value of the velocity, because what we're going to do is we're going to resolve in the direction of acceleration using F equals ma, so Newton's second law, and reminding ourselves, because this is horizontal circular motion, we've got v squared, acceleration is v squared over r. And just remind ourselves from the question, r equals 80. So resolving horizontally in the direction of acceleration, there is nothing acting in the direction of acceleration other than actually the reaction. So I'll get r sine 12 is equal to the mass, which is 1200, times the acceleration, which is v squared, all over 80. So what we get is 12,022.73 sine 12 is equal to 15 v squared. And so if I divide by 15 and take a square root of both sides in this order, what we get is that v is equal to 12.91 meters a second to 2 decimal places. Let's have a look at how the marks are awarded in this question. Okay, so method mark if you've resolved vertically, it has to be vertically. We get an answer mark if you've got the answer for the reaction as 12,022.73 newtons. Next, we get a method mark for resolving vertically, and you also get an accuracy mark if this is resolved correctly. And finally, we get that accuracy mark for that final answer, and that's for correct answer only. Okay, I hope that all made sense and you understood that question.